Now we are going to learn about scheduling algorithms. So before going to learn about scheduling algorithms, we must know the difference between preemptive and non-preemptive. So preemptive algorithm, in this forceful preemption of a process can happen. So preemption can be due to anything, like it may be due to priority or it may be due to time quantum. So let us consider time quantum as a scenario. So in the time quanta, each process will be given particular amount of time to execute. After executing for that particular amount of time, it will be preempted. CPU resources will be given to another process after that particular amount of time. So what you can understand from this, the process is forcefully being preempted. Whereas in non-preemptive, once a process starts executing, till it completes, it won't be preempted at all. So I hope you understood the difference between preemptive and non-preemptive. Now we will see scheduling algorithms. First come, first serve. Schedules based on arrival time of a process. Process that requests CPU first is allocated CPU first, implemented using FIFO queue. Now let us consider two processes, P1 and P2. P1 arrived at time 1, P2 arrived at time 2. Now, since P1 came first, it will be allocated CPU resources first. After the completion of P1, then CPU resources will be allocated to process P2. Next, shortest job first. One another point to note in FCFS is FCFS can cause longer waiting times, especially when the first job takes too much CPU time. As I have told in the above example, P1 and P2. Suppose P1 takes very long amount of time. It keeps on executing. Then then process P2 has to wait indefinite amount of time. So this might happen in FCFS. Shortest job first, non-preemptive. Process which have shortest burst time are scheduled first. So it is based on burst time. The process having shorter burst time will be scheduled first. If two processes have same burst time, then FCFS is used. Suppose P1 and P2 have the same burst time, 2 and 2. Then their arrival time is checked. If P1 arrives first, then P1 is given CPU resources. So one thing you should take note of in SJF is SJF may cause starvation. In which case, so consider this situation. When the long process is there in the ready queue and shorter processes keep coming. By longer and shorter, I mean their burst times. Suppose a longer burst time process is there in the ready queue, but shorter processes keep coming. So you have to continuously assign the CPU to these shorter processes, and longer burst time having process must wait in the ready queue indefinitely. So it is starving. Hence, starvation might happen in SJF. Shortest run, remaining time first. So this is similar to SJF, exactly same as SJF, but one thing that is different is it is preemptive, but SJF is non-preemptive. Next, priority-based scheduling. It can be preemptive or non-preemptive. Non-preemptive, we'll consider this case. In non-preemptive, processes are scheduled according to their priorities. Highest priority process is scheduled first. If priorities of two processes match, their arrival times are considered. So let us consider P1 and P2. P1 has priority 8, P2 has priority 6. Now P1 will be assigned CPU resources because it has a higher priority value. If P3 came next, P3 and P2 both have priority as 6. Then CPU resources will be allocated to process P2 because it came first. Its arrival time is less compared to P3. Round robin scheduling. It is preemptive. In this, each process will be assigned a fixed time quanta. For that particular amount of time, the process will execute. Then it will be preempted. Then next process in the ready queue will be assigned CPU resources. CPU scheduler goes around the ready queue allocating CPU to each process for a time interval of up to given time quanta. Another point to note in time quanta is If time quantum for round robin scheduling is very large, then it behaves same as FCFS scheduling. So I hope you understood all the scheduling algorithms. Thank you.